And am I like good in front of the camera here too?
Yes, you have until basically the chair until
Okay.
the other side of those double doors. So
Okay.
there's plenty of room. All right. We are unmuted. We are live.
Okay. Awesome.
Ready when you are.
All right. I'll give it just one more minute if that's okay.
Okay. And again, I'll give you like a wave or something.
Yeah. I can fortunately see my clock okay here too, so
Okay.
I'll try to be mindful. And I have till 5 till?
Yes.
25 minutes? Okay.
Like I said, there's no one after you or going to lunch after. So if you're in your conclusion and then we hit 55,
Okay.
Like,
And can I ask the back of the room, like if they can't hear me, just to like let me know?
yeah.
I'll just ask them real quick. Can I ask you guys a favor? If at any point you can't hear my voice well enough, can you just like give me a signal? Yes, a wave or something so I can grab one of the mics. I think I'll be okay, but just in case. All right. Hey, everybody. I'm Brandy Smith, and today I'll be talking about mastering observability for DevOps success. I have over a decade of experience in the tech industry at companies like Google, AppDynamics, AWS, and I'm currently at Grafana Labs. I've been at Grafana for about 2 years, and I just moved into a leadership role on our observability architecture team. If you want to connect with me, you're more than welcome to. That's a QR code to my LinkedIn. I'm always more than happy to answer questions, whatever. I'm an open book. And so today's session, I know that this is such a huge topic. And so we'll cover a lot. Again, you're more than welcome to reach out with any questions. And Kyle's session, Kyle over there in the white shirt, he's also going to be talking a little bit about observability tomorrow and go a little bit deeper than I will today. But this session's all about going into the basics of metrics, logs, and traces to understand what's happening inside of your systems. We'll talk about core principles of observability, how to architect observability into your applications, and then I've got some good resources for you as well. And so just to prime for the session here, imagine trying to drive a car blindfolded. No dashboard, no rearview mirror, no sense of what's happening under the hood. Kind of sounds impossible, right? That's essentially what managing cloud native applications and microservices looks like without observability. Where systems are more complex than ever, observability isn't just nice to have, in my opinion, it's mission critical. Now, if you think back to traditional monitoring approaches, they really fall short in providing deep visibility across really complex systems. I think back to, a monolithic application. It was pretty easy to monitor something like that. You had, one place that you're trying to monitor, but microservices architecture, it's pretty complex. And when you think about the implications of poor observability, they're pretty significant. It impacts, the ability to meet SLAs, and the inefficiencies ripple throughout the DevOps lifecycle. It slows down the ability to deliver features and fixes. And in today's fast-paced world, it's simply unsustainable. You have the increased risk of service outages and a slower pace of innovation and higher operational cost. So all of that said, what exactly is observability? There are 3 main types of telemetry data that are broadly considered the pillars of observability: metrics, logs, and traces. So I'll start with metrics. This is the most common of those 3 pillars. Metrics are pretty simple. They're usually single value numbers that give an indication of one small part of the environment. They can be real-time indicators if you're flying a plane. For example, these are the gauges that you would use all the time. You can glance at them and understand the overall health of your environment very quickly. They can be arranged over time and form a time series and show trends. Logs are going to be the oldest of the telemetry signals, and they started when programmers or system admins needed a way to send data from their environment. Think about like syslog, for example. These were intended to be human readable and as such are freeform and pretty verbose. Now, using the airplane analogy, If you think of logs like a flight recorder, lots of useful information to go through after a crash, but they're far too detailed to glance at quickly. And then there's traces. Now, while metrics and logs show data coming from an individual component of the systems, whether it's a machine, a container, or service, traces provide you the relationships between the components in a particular context. Now, the airplane analogy kind of falls short a bit here, but you can think of it kind of like a tracking system, tracking, similar to what's used in air traffic control towers. They give you a wide and global picture, tell you, the flight routes, the positions, their speed, and if there's risk of bottlenecks. Tracing, and more specifically distributed tracing, came about with the rise of microservices. It gives you the ability to observe the service calls and invocations made through the life of a request in your system. Very similar to APM, or application performance monitoring, but it has a focus on looking at distributed systems rather than a monolithic app. It assembles the events into a timeline. It gives context for how services work together, and it shows how components build up systems. Now, logs and metrics are pretty well understood at this point, but tracing is much more complex. I actually get questions about tracing more than anything these days. It takes more effort to implement, and this is the part of observability that some folks struggle with. And so if we bring this back together, when an incident happens, the 3 pillars answer important but different questions. Is something happening, and what is it? Where is it happening? And of course, why is it happening? And any one of these gives a part of the picture, but to really fully understand your applications and environment, you're going to need all 3. And then correlation between those 3 pillars is so important to quickly solve issues. And so let me give you an actual example. A request latency is measured and goes above a threshold. That will then trigger an alert. And of course, you're notified of that alert. You then fire up a dashboard and you look at the metrics trend. Then you drill down into the logs and using the same labels. Now, let's apply that to DevOps for a second and the labels. You could correlate on service name, for example, to find that data retrieval isn't working for some request. And then you jump to the traces associated with those log entries to get a detailed look at how requests are being handled to find that a database is timing out. With that, you have the root cause and you have the specific context, which requests potentially, and even request parameters are causing a database timeout. Now, without correlation of metrics, logs, and traces, it would be extremely complex and time-consuming to find out what happened. So all of that sounds great, but how do I actually start collecting observability data, and how do I actually architect my systems for this? Now, before digging into the exact specifics of how, what type of strategy should we be adopting? All of these 4 components can be implemented independently, in parallel or in sequence, and there's no direct dependency between them. So you could get metrics, logs, and traces from your app, Kubernetes, so monitoring your applications, requests, and all of that from Kubernetes. Black box monitoring, this is going to be your typical synthetic monitoring. And then load and performance testing, so monitoring things before they go out into production. And then now let's talk about the journey and implementing here. So observability is a journey. It's an iterative process, and it's so important to remember that. Step by step, one at a time, and it does require careful planning. I also like to stress that feedback loops and continuous improvement are part of that journey. And it's not all about technology, it's also about the people and process. And what I mean by that is kind of coming together and getting a list of all of your services, your apps, and then, of course, setting up the telemetry, which we'll talk about here in a second, like how do I collect metrics, logs, and traces. But coming together and say, okay, how is this application written? How am I going to actually instrument and collect those signals? Then actually setting up the telemetry, having that shift left app dev, alerting. So what do I want to alert on? What does a good alert look like? We want to make sure we don't have alert storms and alert fatigue, because that's just not fun for anybody. I've been there. I've been on the receiving end of an alert storm. And then planning for incidents. So do you have an incident response process in place? And if you don't, what does that incident response process look like in the future state? Now, another best practice here is observability as code. Keeping things as consistent as possible and portable. You want to be able to leverage the same dashboards, alerts, and workflows regardless of if you're in a Kubernetes cluster or a VM. And you want deployment and addition of these components to be as seamless as possible. And so that means baked into your CI/CD pipeline and leveraging, of course, observability as code. And this is kind of an architecture of what that could look like. Now, what tools do I use for this? There are many open source solutions for observability. So you can use OpenTelemetry, Grafana, Prometheus, Loki. I could go on and on and on listing these out. I see folks adopting these day in and day out as part of their observability strategy. And when you combine all of these tools into a dashboard, you can truly achieve context across every layer of the tech stack and true observability. And it doesn't have to just apply to DevOps. I've actually worked with folks that have observability on their network. Serverless applications, I've got a blog out there that talks about instrumenting Lambda, Fargate, all of those with observability. And so, what does it look like to instrument with open source tooling? First, you instrument with an agent. Then you do your data collection. An agent can look like something like OTel, different APIs or libraries. And for some of them, we have auto instrumentation, depending what you use. Your data collection could be something like, I've called out the Grafana agent and OTel. There are many, many different collectors out there. I like to reference OTel a lot because it is vendor neutral. If you're using something like an Elastic or something like that, you decide, hey, I want to move to Grafana, or I want to move to Splunk, or anything else with OTel you can pick up and move. It's vendor neutral. Then you've got your backends. Your backends are where you're going to store that telemetry data. Prometheus, Mimir is a scalable version of Prometheus. Tempo is going to be tracing, and then logging, Loki for logging. And then the UX is going to be how you visualize all that data. And then an architecture. So what does this actually look like? This is an architecture for that. So you've got your application and infrastructure over to the left-hand side. Throw in that OpenTelemetry collector in the places where you want to collect and instrument and collect. You can have Prometheus clients also scraping and remote writing. Your different infrastructure pieces you can also scrape and collect from there too, and remote write. Metrics, logs, and traces. I've got Grafana Alloy out there collecting as well, but you could have any observability collector in place of it. And then shipping to, I put Grafana Cloud there, but you could use any open source to visualize there. Now, my call to action to you. Go try this out. Grafana is open source. We have a free tier in the cloud, but you can also set it up on-prem. Go try this out. And the cool thing is, we have demo data and dashboards. So if you don't want to go and instrument an app, you just want to say, hey, I want to play around with observability data. The QR code will take you to like the Grafana Cloud free tier link. But this screenshot that I put here are free dashboards that come out of the box. Over on the left-hand side, you'll see the call out under apps for demo data dashboards. And when you install those, it automatically installs demo data sources. So for weather data, Kubernetes monitoring demo, application observability, and Quick Pizza SRE demo, but it's got metrics, logs, traces, profiles as well. I didn't touch on profiles because I didn't want to get too deep in the weeds, but it's kind of referred to as the fourth pillar of observability these days. But with this, all on the free tier, forever free tier, you can go get your hands dirty with observability data without having to instrument anything. So you can kind of see, oh, this is the value. This is how it correlates and works together. And so all of that said, I know it was pretty high level, but I wanted to make sure we had time for questions. And I definitely recommend, if you found value in this and thought, hey, that's really useful and could help me, attending Kyle's session tomorrow because he goes a little bit deeper in the weeds and talks about also some stuff we're doing with AI as well. And so Kyle's over there, in case you didn't know who he was, but he'll be talking tomorrow. And any questions? Yeah.
So you said the hotel is open source,
right? Yep. Open source CNCF project. Grafana and Prometheus are also CNCF projects as well, and completely vendor neutral. So it is a collection of libraries that is set to standardize observability signals. It also helps translate Prometheus, so it works with Prometheus, and there's a translator between Prometheus and OpenTelemetry so that you can use those interchangeably. Yeah.
It's open source in the ingest layer, so like she said, you're not locked in with data log, Elastic, or whatever. That being one of your biggest data points for your company, right? There's a lot of expense there. So.
Yeah. I like to suggest folks when they're like, how do I make sure I'm not getting locked in? Like we had this big 10-year contract with XYZ company that's many millions of dollars. How do I make sure I'm not stuck with something like that again? I'm like, OpenTelemetry is the way. It's the future. And it used to be limited mostly to traces back in the day. And now it's metrics and logs compatible. I want to say we're getting there with profiles, but I don't want to, I haven't done a whole lot of research into the profiling side. And one other side note, I didn't mention it, but like Jaeger, you'll see Jaeger Zipkin as well on the tracing side, not just Tempo. I brought up Tempo up there, his limited room on the side and such, but you'll see a ton of different libraries and whatnot for OpenTelemetry. And one other side note on the OTel side of things, who in here does any kind of like cloud work, cloud development? The whole room, right? So if you're using things like AWS, for example, AWS has a layer for OpenTelemetry. So you can, a Lambda layer, for example. So if you have a Lambda function, you can tick that box to turn on the ADOT layer, and you're using OpenTelemetry with Lambda. I'll tell you, when I first started using OpenTelemetry, I had a Lambda function that was failing consistently, and I couldn't figure out why. And I had CloudWatch turned on for it. Still couldn't figure out why that Lambda function was failing. I was debugging it to no end. And I was like, let's see if I can get OTel to work with it. I knew a little bit about OTel at the time, but not a whole lot. And when I turned that ADOT layer on, I was mind blown because I could trace exactly what was happening, and I debugged it. And I don't know, it was like less than 30 minutes on the debugging on that one. So if you do work in the cloud and you want an easier route to OTel, versus using the collector, ADOT is a great way to get started. Yeah.
I have a question. I've never done anything like this, but I'm just curious about the performance impact or about AWS or like that as well.
Yeah, it's usually very minimal impact. So I know that Grafana, for example, we have some stuff published on what the performance impact is of our collectors and such, but it's usually very, very minimal performance impact. And I don't have the numbers off the top of my head, Kyle or Travis. I'm pointing to you because I know, Travis, you've done a lot of work with this too.
The protocols and all that stuff is usually meant to be like they're very
lightweight.
Super lightweight because of that.
Yes.
If you're using an agent like Alloy or the OTel collector, then yeah, that's the push kind of way. But Prometheus also has you scrape the metrics from
Yeah.
Right? So it's a pull method.
Yeah. It just does a remote write typically. And like, for example, if you're using like the Prometheus agent, it's typically just a YAML file that you go and trigger it and then remote write. So it's very, very lightweight, very minimal. I have seen, I will give a caveat there, no naming or anything like that. I have used collectors that were not vendor neutral, not, I won't go into anything like that were running some other type of processes, and they used a lot more memory. So I will say, do your research, do your testing. I like the open source vendor neutral approach because a lot of times you'll find it is very lightweight and it's not running any under the hood processes there.
No crypto mining underneath.
Exactly.
What's my CPU?
Yeah. And that's almost exactly what I was saying. This was many years ago, but not an open source agent, nothing like that. And it was spiking CPU for some reason. Like, what's going on here? So
Crypto mining?
Was not crypto mining. I think it was basically looking to see if you had any other agents because it wanted to be the proprietary agent running on the machine. This is APM world, so it was, yeah. What else? Any other questions? And I do a lot of webinars that go like webinars and workshops, hands-on workshops that get a lot deeper in the weeds too. I'm always sharing them on LinkedIn. So like I said, feel free to connect. If you think of questions after today, I'm an open book. You're more than welcome to reach out directly and ask. I won't get mad at a direct message anytime. Yeah, of course. I believe it was on this one. And if there's no other questions, thank you for your time today. For this, do I just stop sharing and unplug?
Yes, you can stop sharing, and then I think the only thing we really need is just the microphone.
Oh, yeah.